Okay, so when we talked last time, I said there were three logistical items that I needed to talk about before we were done with the intro to classes. We talked about two of them. We talked about constructors. We talked about splitting your code up into three files. So the only thing we have left is we're going to talk a little bit about const. As it turns out, there are some problems with the code we've written so far having to do with const. Here's what we need to do. When you define a member function, sorry, excuse me for a second. When you define a member function, you have access to the calling object's private data members, much the way you would if the object was a pass by reference parameter, right? So that's considered a bad thing in C++, right? In C++, there's this philosophy that as a matter of safe programming and also as a matter of self-documenting code, we want to make it so that if something is not getting changed inside a function, we want to make that clear and we want to enforce it. Okay, that's the deal with pass by value and pass by reference. Anybody want me to say that again? Okay. So the problem is that, for example, in our print function, let's look at the implementation of print. If I can find it. We don't want the calling object to change, but we could change it, right? Inside my month function, I could say, inside my print function, I could say, month gets 47. And then back out in the client program that called print, I'd end up changing the calling object. That's a bad thing, at least in C++ philosophy. So the way we fix that in C++ is we just put the word const out here next to the function header. Okay, so that's not the totally precisely correct way to say it, I guess, because it's actually now part of the function header, but it looks sort of like it's hanging out there after the function header. That's basically all there is to say about that. The word const there at the end of the function header means the calling object cannot be changed. Okay, so now if I say month gets 47 in here, I'm going to get a syntax error. Okay, let's just play with that. Got to make my prototype match, of course. And so right now, if I try to execute this code, it occurs to me that I didn't try to execute it before, so hopefully we're okay here. Error cannot assign to non-static data member within const member function print. Okay, as usual, the error messages are a little bit hard to understand, but hopefully you get the idea here that the reason I'm getting that syntax error is because of the word const here. If I take the word const out, no problem, I can do that. Okay, but that's a bad thing. I don't want to be able to do that. I want to make it so that things cannot change inside the print function. So I'm going to put it back. Okay, so we're seeing the word const thrown around a lot here now, and I'm just going to put it out there that C++ is sort of famous for making this const thing really complicated. One of the textbooks that I use sometime actually has like every time a new use of the word const comes up, it has this like special big box that it puts out there, and it lists all of the 7 different uses of the word const in C++. So it's kind of a big deal. I would consider this to be the third use of the word const in C++, right? So let me just review that. First of all, we can use const just in the very basic sense of making a constant, making a variable const instead of variable. Any questions about what I mean by that? So I could have a const here. Right, so that's the most basic use of the word const. It's just saying this is not a variable, it's a constant. Okay, so we put the word const in front of the declaration. The second use of the word const we've seen has been in parameter lists. I don't think we've done that here, right? No, but when we studied arrays, I said, if your array is not going to change, then you should put const in front of it in the parameter list just to indicate that the array is not going to change, because otherwise it's passed by reference. So that's the second use that we have seen of the word const. And so this is the third use of the word const. In this case, what we're saying is, if you put the word const at the end of a function header, it means that the calling object cannot be changed. Okay. It does not make sense to put the word const at the end of a function header if the function is not a member function of a class, right? In that case, you'd get a syntax error, and the compiler would say, hey, wait a minute, this is not a member function of a class. There is no calling object, so it doesn't make sense to put const here. All right, any questions about any of that? Okay, so Joseph is asking about basically what happens when const is in front of a function prototype. And that is not something we've seen or done yet. And I'm just going to say that it's a little complicated, so I don't want to go there too much right now. But the second half of your question is correct. Yes, if you put it at the end of a function prototype, the calling object of the function cannot be changed. It doesn't make any sense. Like if I put, so this is a little bit of a digression. So if you're struggling to just keep everything in your brain, you can just shut down for 60 seconds here. But if I put the word const here, it doesn't really change anything, because when I return a date object to the calling function, what I'm returning is a copy of the date object anyway. So making it const doesn't change anything. All right, that's all I'm going to say about that for now. We'll talk about that a little bit more later. Okay. Right. So for right now, until you see otherwise, I'm just going to say we have not talked about putting const in front of a prototype, so you shouldn't see it that way. Okay, so just let's go through and see where else we need const, okay? How about my constructors? Are my constructors supposed to change the calling object? Right, yes, that's the whole point of the constructor, right? The constructor is supposed to be initializing the calling object. So I do not want const on my constructors. You will never want const on a constructor. Okay, how about my read function? Is my read function supposed to change the calling object? Okay, let's look at how read is used in the client. date2.read. What is supposed to happen to date2 when I call date2.read? Right, exactly. Date2 is supposed to be modified by putting whatever the user enters into it, right? So the whole point of the read function is to modify the calling object. Does that make sense to everyone? The answer no to my last question was quite emphatic, so I just want to make sure everyone understands why. Just scanning, so it's a bit confusing. Okay, so someone asked to go over calling object again. I'm glad you asked, because that's definitely not much is going to make sense if that's still fuzzy at this point, right? So in this client program, the calling object is just the object in front of the dot. It is the object that is calling the function. So on line 25, date1 is calling the print function, so we call date1 the calling object. On line 29, date2 is calling the print function, so we call date2 the calling object. Does that help? Because right, so read is, let me try to address that. Read is just scanning existing information, that's right. But in our case, what it's doing is it is scanning that existing information and putting it into, in this case, putting it into date2, right? So the question is not whether there's existing information, the question is not about where the information is coming from, right? The question is date2 going to change as a result of it calling the read function? Okay, so I hope that helps. So date2 is the calling object here. We'll go look at the read function again. You'll recall that inside the read function, when I say cin month, that means get some input from, existing information or whatever, but it doesn't matter where it's coming from in terms of this discussion. We're getting some information and we're putting it into the month data member of the calling object, which was date2. Okay. Anybody want me to talk about that some more? The bottom line here is that this should not be const, because we're modifying the calling object. If I put const there, I'd get a compiler error, right? Just the same as I'd get a compiler error here trying to change month. If I have const here, I'm going to get a compiler error here. Okay. Anything else? I mean, I sort of have this feeling like it's not a bad thing for me to sort of keep talking about this. Hopefully, the more times you hear it, the more it'll sort of start to make sense. Okay. All right, so we're done looking at read. Let's go back and finish going through our functions to see which ones should be const. Set should be I was going to ask it, but I just told you. Pretend you didn't hear that. Okay. Does set change the calling object? Do we want set to change the calling object? Before you answer that, let's look at the client. Here's where we call set. Do we want the set member function to be able to change the calling object? I have one vote for yes. Interested to see if anyone else has any thoughts about that. Sure. Yes, of course, that's what the set function does, right? It changes the calling object. So we do not want the set function to be const. All right, comes before. Do we want the comes before function to be able to change the calling object? And let's look here. When we call the comes before function, do we want it to change the calling object? All right, looks like I have 4 votes for no. It looks like now I have 5 votes for no, right. The comes before function does not change the calling object. It's just gonna compare things and return true or false, right? So the comes before function should be const. Oops. Nah, that comes before. Okay, any questions about that? All right, let's look at increment. I think the best way to think about this is to look at the client and see how it's intended to be called, right? Date2.increment. Is the increment function supposed to be able to change the calling object? Yes. All right, that is correct. The point of the increment function is to change the calling objects. We are not going to make it const. How about increased by? Should the increased by function be able to change the calling object? Okay, so let's actually look at what happens here, right? In my testing code here, I actually specifically say, after setting date 1 equal to date 2 plus 12, date 2 is still, and then hopefully it's supposed to print out the same value that date 2 was before. Right? So after this function call, just looking at what I have here for my testing, I am checking to make sure that date 2 has not been changed, right? Let me put this another way. So in case you haven't figured it out yet, I am arguing that it is not supposed to change the calling object. And that's actually pretty critical, right? What if the analogy is this? What if I had int I and j, and I said I gets j plus 12. That's the analogy to what I'm doing here, right? So in those 2 lines of code, do I want j to change? Am I expecting j to change? No, right? The plus operator there just calculates what j plus 12 is, and then it returns that. Right, it's not changing the calling object, it's changing something else. That's probably true. I guess I would say the point isn't even so much that it's changing something else, but that it's returning something, right? Yeah, let's go to the increase by function. It's returning a value to set the thing on the left to. That is correct. I think I'll just make this into a comment for now. So if we go look at the increased by function, right, there's nothing in here that is modifying the calling object. I'm creating a new local variable of type date. I'm doing stuff to that local variable. And then I'm returning that local variable, but I do not want to change the calling object. Okay. Anybody want me to talk more about that? Okay, so this is const. So I'm kind of in my mind trying to think about what made it seem like increased by should not be const. And I guess maybe whoever asked that question was on the right track. I'm thinking maybe the misconception was that you're recognizing that something is changing. And so you're saying it shouldn't be const. So hopefully it's clear now that that's not what matters. What matters is whether it's changing the calling object. We're very specific. Okay. All right, so we went through all of our functions and we figured out which ones needed to be const. Any questions before we go on to the next thing? Wow. Wow, meaning wow, we have to be very specific. Anyway, it doesn't matter, I guess. Okay, so we're not quite done talking about const because there's another situation that's going to come up. So this would be uploaded to rewatch. Yes, I will definitely upload this video right after lecture today, you know, unless, I don't know, there's a fire in the building or something. It's const on the right for the calling object and const on the left for what's being returned. So I'm sort of trying to avoid talking about const being on the left. I'm not sure why there, but so I'll say another couple words about it, but I just want you to know that it's okay if you don't care. For now, I could just say, you know what, const doesn't belong on the left. Just ignore that. Don't even think about const being on the left. Okay, but just since you asked, I'll just do 20 seconds on it. If I put the word const here, what the word const is modifying is the return type. So instead of returning something of type date, I would be returning something of type const date. So in a sense, you're correct. It would be about what's being returned. Okay, and this will come up later in the course, but it's there are some subtle issues with it, and so I want to try to avoid it for now. Okay. So here's the other situation that we need to fix here. And this students for some reason have a hard time with this, and I think the reason it's confusing is that I'm about to tell you, and we've talked about this briefly before, so maybe it won't be confusing, but we're going to use pass by reference for something completely different from what we use it for. So sort of be open-minded about this and think, okay, we're using pass by reference, but it's not necessarily just because we need to change that value. Okay, we're going to be using it for a different purpose. And I think I mentioned this when we were talking about structs, right? I said never pass a struct by value. I don't know, maybe I didn't. But here's the rule, okay? Very straightforward rule. Do not pass an object by value. Okay? Wayne, I'm looking at your question and I apologize, but I don't understand. I'm trying to change value. I'm not sure what source value is. This applies to classes only. Well, an object, when I say an object in this sentence, what I mean is the definition of object that we have been using, which is it's a variable that is whose type is a class, right? So for example, a string variable is an object because string is a class. And so I would say do not pass a string by value. This is a separate rule. Well, this also applies to variables that are structs, okay? The point here being that it's a variable that contains multiple parts, multiple components, right? Okay, so the rule is do not pass an object by a value. Have we violated that rule in this class? So here, that's all of our function headers, right? Well, I guess I should include these two down here, okay? So my question is, look at all of those parameters and tell me if there are any situations in that highlighted code where you see an object being passed by value. Right, so how about date? Is there an object being passed by value in that function? No, because there's no objects, right? Those are just regular old int variables. We're not calling those objects, okay? So are we good? There are no examples in this class of parameters that are objects being passed by value. So what about this? What about this parameter right here? What's going on there? Other date is an object, right? Well, there's a const there, but that has nothing to do with how we're passing the parameter. Right? I'm asking, is this parameter an object and is it being passed by value? That has nothing to do with the word const out there. That's a completely separate question. Well, it's passed by value because in C++, anytime you pass a parameter and you don't have an ampersand there, it's passed by value. Except for arrays. Thank you, Wayne. That's true. I was sort of trying to avoid that caveat, but yes. Other than arrays, anytime you have a parameter in C++ and there's no ampersand there, it's passed by value. Is that clear to everyone? Okay, so bottom line out of all that last 5 minutes, I thought we didn't want to pass it by value though. That is correct. We do not want to pass it by a value. That's exactly the point, right? The rule here is do not pass an object by value. In our code, we are passing an object by value. Everyone clear on that? So we just had a very complicated discussion for what, about 5 minutes or so. But here, that's the bottom line, right? The rule is do not pass an object by value. In our code, we are passing an object by value, so we need to fix that. Anybody want to say you're not clear on something there? Yes, not clear? Double negative, huh? The only object that is a parameter in these functions is that one right there that's highlighted. That is correct. So what we're talking about here And Angela, I'm not sure if the question was just not precise or if there was some confusion underlying it. So I'm just going to pick at it a little bit. The question is not about any object in these functions. The question is very specifically about the parameters that these functions have. So I'm just looking at the function header and I'm looking at the parameters and I'm looking for any parameters that are objects. And in that case, the answer to the question is that highlighted code is the only object being passed as a parameter by any member function. Okay. So the solution to this is we put an ampersand. Now it's passed by reference. Okay. I'm pretty sure I talked about this with structs, but that's okay. I'm happy to say it again. But the reason that we do not use pass by value is that it's too inefficient. Okay, so I'm going to explain why it's inefficient. It's not super important at this point that you understand the details. If you could just take my word for it that using pass by value for an object is too inefficient, so we're not going to do it. Okay, but basically with an object, with pass by value, you have to make a copy of the argument. So if it's an object, that could use up, that's going to waste some memory, but it's also going to waste some processing time because you have to go through the process of creating the copy. Okay. All right. Again, I did a lot of explaining there, and it's always nice to know the reasons behind things. And eventually you will want to understand that. But for now, as long as you understand, do not pass an object by value. That's what you need to understand. Just to confirm, somebody asked, is int in month an object? The answer is no. An object is a variable whose type is a class. Int is not a class. Int is a primitive type. All right. Any other questions on this so far? Then why is struct an object? That's a tricky question. Why is struct an object? Well, struct is similar to a class in that it's an aggregation of several primitive variables, right? To be honest, I'm not sure I would refer to a struct as an object. I certainly wouldn't qualify as object-oriented programming if you're using structs. So I would say a struct is not an object, but it's still the same rule applies in terms of not passing it by value, but we're just not talking about structs right now. We're talking about objects. Did that? Okay. Okay, so we're good because we're not quite done talking about this, but we're sort of at a point where I just want to do a check and see if there's any questions. There's one more step to this. Here's the problem now. Now we have violated our rule of good practice about having a parameter that should not be changed inside the function, but can be changed inside the function, right? So now I've got inside my comes before function, I could say, before I get started here, let me just set year equal to 2035. that would be fine. That would be totally fine with the compiler. The compiler would say, okay, that's cool. You can change that. But that's not what we want. I'm sorry. I totally messed that up. I meant other date dot year. Okay, so this is the problem. We don't want, we made this reference, we made this parameter pass by reference. That's a good thing because now we don't have that inefficiency. But the problem is now we've made it so that this function can change other date dot year. Okay. So the way we fix that is exactly the same way we fixed that same problem. We discussed the same problem when we were talking about arrays, right? Arrays are always automatically passed by reference. So when we've got a function that has an array as a parameter, we want to make it so that it can't be changed. Anybody remember what the solution was with arrays? Const, yes. So that's what we're going to do with objects. So let me just summarize everything I just said. When you pass an object as a parameter, instead of pass by value, right? So when you would normally want pass by value, you're going to use const ampersand instead. Okay, that is the 3-second summary of everything we've been talking about for the last 10 minutes. Anybody want me to talk more about that? Okay. So just to summarize everything we've done so far today in the last 45 minutes, which is a little more time than I expected to spend on it, but that's okay. What was the second const for again? The second const being this one out here. Okay, so let me summarize. What I'm going to do is I'm going to summarize everything we did in the last 45 minutes. We've done two things. What I have there in the comments, it was part 2, okay? The first thing we talked about was when a member function does not modify the calling object, use const at the end. Okay, so we're talking about two completely different things here, right? So if you see the word const twice in this function header, just have to keep in mind this is two completely separate issues. Don't try to make them sort of be the same. Let me answer that in a question in a second, Joseph. But so let me just, these two words const here mean completely two separate things, okay? The const at the end is about whether the calling object can be changed. The const in front of the parameter is about whether the parameter can be changed. Okay, so if we look inside our comes before function, we've got two objects here in question. We've got, well, let me get rid of this. And you can see that right here, right? We've got the year data member of the calling object, and we're comparing it with the year data member of other date. So there's the calling object and there's other date. This const here makes it so that other date cannot be changed. This const here makes it so that the calling object cannot be changed. Okay. So Joseph, to your question, the question was, we do not want to pass an object by value syntactically. But it is okay to pass an object by value if we use the const ampersand instead of just the usual pass by value syntax. You know, I could say yes to that, and you'd probably be okay and write your code correctly, but I'm just going to be technically correct here and say, when I use constant ampersand, it's not pass by value. It accomplishes the same thing as pass by value without having to make a copy, but technically it's pass by reference. Okay. Okay. So that one of the things that's confusing about that for students is they're like, well, if we want it to be pass by value, why do we have an ampersand in the first place? What's the const doing there? It's sort of a two-step thing, right? We need the const there because we have the ampersand there. We have the ampersand there because we want to be more efficient. So hopefully that makes sense. And if you don't understand any of the reasoning behind it, yes, that's correct. If we pass it by reference, but we cannot change the values. If you don't understand any of the reasons behind any of this, if you just understand those two rules, that is all you need to know for now, at least. Okay. Okay, I think we better move on. Although I am going to need to take a quick 2-minute break here, so I'll be back in just a couple minutes. Okay, so I saw a few notes in the chat, and it seems like it looks like everything got answered correctly, so that's cool. So what we need to do now is completely change gears and start on a completely new example. Basically, what we're doing now in the textbook, I think the chapter is just called More About Classes or something like that. I tend to call it operator overloading because that's probably 80% of what we're doing. Maybe 90%, I don't know. But so you can think of it as, okay, now we're going to be studying operator overloading. But some other things will come up as we go. So basically, in C++, we can give new meanings to some operators. So I think I'm going to let me gonna get rid of that, get rid of this. It's going to okay. So in C++, we can give new meanings to operators. So let's take, for example, let's say that we have a fraction class, and this is actually what you all are working on. But if you haven't started it, that's okay. This should still make sense. So let's say I have a fraction class and I've got three fractions. And let's say that I have I want to have a function in my fraction class that adds two fractions together and returns the result. I would have to do that with some sort of a function like maybe named added to, right? So I might say F1 gets F2 dot added to F3. Okay. Wouldn't it be great if we could actually just make it so that C++ understood what we meant when we used the plus operator? And I could say F1 gets F2 plus F3. Turns out that in C++ you can do that. That's something that you cannot do in Java. When the creators of Java created their language, they decided that it was just not a helpful feature for a variety of reasons. Personally, I actually think it's very cool. One of the fun parts about C++. And just to kind of expand on this, what if I wanted to add four fractions together, F2 plus F3 plus F4 plus F5, right? What if I wanted to do that, but I didn't have a plus operator? You can imagine that this would get pretty ugly pretty fast, right? I don't even want to attempt it, right? I could do it, but it would be harder to think about and harder to read once I have it. Okay. So that's the motivation here. So what I'm going to do, and this is sort of my favorite technique, we're basically going to be working on one large case study for all of this conversation about operator overloading. So I'm going to start by just setting up an example, and then we're going to start working on it. Okay. The class we're going to write is going to be called feet inches. And when you do the reading in the textbook, you're going to find that there's also a feet inches class in the textbook. So my idea was sort of inspired by that. They're going to be different though. So just as a word of caution, I guess I would say, don't try to make the two examples work together somehow. I think your best bet is just going to think of them as two completely separate examples, because the text author does things a little bit differently sometimes. So just think of here's the example from the textbook. Here's Dave's example. They're two different examples. So I'm going to start with a client program that demonstrates something that I'll want my feet inches classes to be able to do. It's not going to have any operator overloading yet. That's something we're going to change it to once we get something set up and running. So for now, I'm just going to have I'm going to have some feet inches object. So a feet inches object is going to be an object that stores a linear measurement that involves feet and inches. I have tried to think of a better name. I think feet inches is a terrible name, but any other names that I thought of weren't any better. Maybe I could call it something like short linear measurement American version or something like that, but that would be too long. So we're stuck with feet inches. You can imagine that if you were writing a software package that was doing something like, say, architecture or something like that, where you're going to be constantly having to keep track of measurements using feet and inches, this would be something that would be handy. Okay, so here's 3 feet inches objects, you can see from this that I'm going to want to have 3 constructors, right? One that takes no arguments, one that takes 1 argument, one that takes 2 arguments. Anybody want me to say more about that sentence about constructors? Okay, then you can see there's going to be an added to function that's going to add the calling object plus the argument and return the result. And then there's going to be a print function. Okay, so we're going to get this set up. Then we're going to introduce some operator overloading. And then we're just going to start adding more and more operators to this class so that you can see the operators working in a variety of different situations. I'll just say right up front that really in terms of operator overloading, I'm going to tell you everything new you need to know about how to overload an operator in about 2 sentences. Everything else is going to be just complicated situations that come up and how to deal with them. And also, maybe even more so, really understanding at a deeper level what the operators do so that when we overload them, we do it correctly. So sort of an interesting topic. We're going to learn a lot as we go about operators that we've already been using, and we're going to understand them in more detail than we did before. Okay, so here's my code for the class. I'm going to actually # include H. H, and there's my code. Okay, there is one new syntax item that I need to discuss here. Actually, I think it may have come up before, particularly in the textbook. I'm pretty sure it's come up before, but I'm going to treat it as if it was new. And that is this syntax here. These parameters are called default parameters. What that means is that I provide a default value for the parameter, and then if the client program doesn't provide 2 parameters, the function is going to use the default value for the missing parameters. Okay, so, and to be clear, I mean, it's pretty simple. If I call feet inches, if I create a feet inches object with no arguments, both of the default values are going to be 0. If I provide 1 argument, as I did here, right, the F2 is going to, I just provided 1 argument. That 1 argument is going to go into the first parameter. And then because I did not provide a second parameter, the in inches parameter is going to use the default value of 0. Okay. What this does is it, instead of having to write 3 separate constructors, I'm just going to be able to get away with writing just 1 constructor. Okay, so this isn't the same as the default constructor date. This is the same as having the default constructor date and also the other constructor date at the same time, with only having to provide 1 function definition. Okay, and as it turns out, when the compiler compiles this code, it's actually going to create 3 separate constructors, 1 with no parameters, 1 with 1 parameter, and 1 with 2 parameters. So it's really sort of a magic way of providing 3 functions, even though you only see 1 in the code. Okay, just another word about the default parameters. In some compilers, it will let you put the default values in the function definition down here instead of putting it in the prototype. But that is not correct in standard C++. So just be careful about that. You know, if you do that, and then Kyle or I goes to grade it and we run it in our compiler, marks it as a compiler error, that's going to be a problem, right? Or maybe more to the point, if you write your code and put the default parameter down here in the function definition, and then you give it to your colleague, and then your colleague is using a different system, that's going to be a problem. So just make sure you put the default value in the prototype, not in the function definition. Okay, just to point out here, I've done a weird thing in that I'm just combining the class into one file instead of splitting it up into two files. Just going to go with that for now to keep things simple. So I've got an added to function. I'm just declaring a temp feet inches object. Temp.feet gets feet.other feet. Any questions about this? This is just a review of stuff we've already done. Do I need to talk about it more? What's going on here? Just let you stare at it for a minute, maybe. Okay, I'm going to go with that. Print function, pretty straightforward, I think, right? I'm just saying print the feet data member of the calling object and print the inches data member of the calling object. Okay. All right. So any questions about this code? I know I just kind of flashed a bunch of code up there at you, and I've taken coding classes before, and I find that to be annoying if I don't get enough time to look at it. So someone let me know if you want to have more time to just stare before I move on. Okay. All right, so here's how you overload an operator in C++. What I'm going to do is in my client, what I want to do is I want to be able to change this to F1 gets F2 plus F3. Unfortunately, right now, that won't work, right? I'm going to get a syntax error. The compiler is going to tell me you can't do that because there is no plus operator defined that takes operands of type feet inches. So I need to define an operator plus that takes operands of type feet inches. Okay. So the first way I'm going to do that is not necessarily going to be the final way we end up doing it, but it's the simplest. Okay. Basically, when the compiler sees this code, it's going to just translate that into this. Okay, so in other words, it's going to treat the left operand, it's going to treat this as if there was a function named operator plus that's going to get called. The left operand is going to be the calling object. The right operand is going to be the parameter. So what I need to do to make this statement work is I need to provide a function named operator plus that takes one parameter. Okay, so if I do that over here, if I go ahead and I say, let's see, the return type is going to be feet inches. Sorry, something's wrong with my notes here. Oh, there we go. Okay. Okay, there's my prototype. Okay, and so what I'm going to want to do in here is essentially exactly what I did here, right? In fact, not even essentially, exactly what I did here. I'm just going to copy and paste. Okay, so now I have a member function named operator plus. And what it does is it adds the calling object plus the parameter, and it returns the result. Okay. So let's give this a whirl. I suspect I'm probably missing something, but let's see how this goes. Oh, look at that. 3 feet 0 inches plus 4 feet 7 inches equals 7 feet 7 inches. Okay, so that was your first time of getting to see the plus operator being defined by the programmer right here. Okay, so I'm going to stop there. I realize I kind of rushed it at the end a little bit there, so probably when we start next Monday, we'll just kind of go through that process again to make sure that we're good with that. I know for right now, you're probably more focused on just the intro lesson because that's the assignment, that's the lab that you'll be working on between now and which is due on Monday, unless I have my weeks mixed up. In that line, which is the calling object. Trent, I think I might have missed your question. So yeah, F2 is in this line, F2 is the calling object, F3 is the parameter. So the compiler sees this code, it's translating it into this and looking for a function named operator plus. It's a member of the Phoenix class. So about pre and post conditions, the bottom line is, so the const is being applied to F2 and F3 here. Yes, there's one const that's being applied to F2 and there's one const that's being applied to F3. That's correct. Precondition, it's actually kind of easier to start with a post condition, okay? A post condition is just saying, okay, here's what is going to be true when this function is done executing. And typically, we use that as a way of describing everything that the function does, right? So if there's output, if the function produces some output, then that should be part of the post condition, right? You know, the value of the calling object has been printed on the screen, for example, could be a post condition. Or the value of the calling object added to the parameter has been returned or is returned or something like that. Okay, so it's basically a way of saying what the function does, except in a little more formal sense. And really, the only thing you need to worry about there is any output it may produce, any value it may return, any changes it may make to a reference parameter. That's pretty much the only reasons we ever call a function, right? For one of those three purposes. The precondition just means, okay, well, in order for this to happen, in order for this post condition to actually be a correct precondition, a post condition, in order for the post condition to actually be an accurate post condition, these conditions have to be true before the function starts executing. Frankly, especially at this level, there's not going to be very many things. And most students, if there's any mistake, they try to put something down as a precondition that doesn't need to be a precondition. For example, you don't have to put down as a precondition that it's a fraction object, right? Because you can tell that by looking at the parameter list. The compiler is going to enforce that it's going to be something of type fraction, right? I'm trying to remember, there may not even be any preconditions at all in assignment, in the lab that you're working on for this week, okay? And again, I know this is your first time seeing preconditions and post conditions. I'm not too concerned about you getting them perfectly. Just give it your best shot. You'll get full credit, and you'll be able to see on the solution. The other thing is, in the lecture notes that I just posted this morning for this lesson, which is lesson 15, there is the class example there is documented with pre and post conditions, so you can check that out. Okay. All right. We're over time, so have fun at lab. I hope that you take advantage of the time in lab to get the help you need on your assignment. Don't forget, there's also tutoring. You can email me with questions. And I will see you all on Monday.
Professor, quick question.
Sure.
Could you possibly post last week's